in the autumn conference, which was for my work on the photoplethysmography signals. So you may be familiar with photoplethysmography. A small sensor is placed around a fingertip where there is an LED light that sends a signal, a photodetector that receives the signal. And as blood pulses through the capillaries, the change in light wavelength is attributed towards blood flow. And the thing which I briefly mentioned in my presentation in autumn was an analysis called the symmetric projection attractor reconstruction, which is quite a mouthful. So most of the time, those of us that use it just refer to this as SPA. It's a relatively simple process. We follow Taken's algorithm to use 3 points from a signal, which are iterated fully along the signal, to change a one-dimensional signal into a three-dimensional signal. So each of these points will be creating a new vector, which is the XYZ coordinates, which are used to create a state space diagram. There are some also subsequent fairly simple algorithms that, in essence, rotate this diagram. So you're looking from the bottom corner diagonally through to the top corner. And this will actually change what looks fairly messy in a 3D plot into a nice triangular shape in a two-dimensional plot. So from here, we'll often use a density plot to look at this. And when I saw this, not only did I think, well, that gives a strong visualization, the maths is relatively simple. I thought there's a lot of impact from this. And when I read into the article, I realized that the authors who developed this algorithm have put forward this table that blew me away, because we have very simple changes to the shape of the attractor. So, if the triangle rotates, if it gets bigger, if there is less a non-uniform density, if it's, the density plot's thicker on one side and thinner on the other, we can attribute these to physiological responses. As I got very excited at this point, I thought to myself, well, this could be the new ECG. This could be something which people don't need algorithms which many clinicians can't understand. They can just use their eyeballs. And so I dived in, and I did the classic overly excited mistake of jumping straight into some clinical data. And I collected some data from patients who were on dialysis. And I was very interested, and a lot of my research is looking at whether the fistula, in other words, the operation where a vein and a artery are connected to allow a point when there can be a regular insertion of a needle, in this case for a dialysis. Sometimes the fistula can create problems. Okay, if there is too much blood redirected away from the hand, we can get something called Steele syndrome. And so I wanted to start applying this algorithm to see if I could detect changes to work out whether or not people are likely to have problems with their fistula or not. And I could see that these are 3 patients, left hand, right hand, left hand, right hand, left hand, right hand. And these are from patients who do not have any problems with their fistula. And here are some patients' data. And again, this is 3 patients, left, right, left, right, left, right. And I was starting to see that there are some differences. They weren't necessarily consistent differences, and I was struggling to try and interpret how I might deal with that. I decided, therefore, to try and use as many different data sets as I could. And I set some students on some challenges doing this using some of the publicly available data. And one of the first things I found is that publicly available data is very messy. They're not clean signals. And so I had to do a little bit of filtering. And I've got some student projects I just want to quickly go over. So the first one was on a data set when it was healthy people, 2 groups, people who exercise, people who don't, and then students break them up in different ways. This first student looked at males versus females. And this is because the equation has been used on ECG signals and claims to be able to differentiate between a male and a female just based on the ECG using the symmetric attractor, the SPA analysis. So I thought this would be a nice, simple process. But I also wanted to be sure I could be relying on the actual consistency. So I had the 2-minute signals in a rested state, split them into minute 1 and minute 2. And from here, the first thing I noticed is that when I'd filtered the original signals, I took out this very important feature within the signal called the dichrotic notch. And so I need to be very careful with how I actually filter. I calculated the area and I calculated the perimeter. And although there were some differences, in reality, there is such huge variability, then it wasn't really a hugely reliable point. I also remember I wanted to see if this is something where clinicians could just use, their eyeballs to look at this. They can eyeball it and say, I can see these changes the same way you would in an ECG. So I asked the students to look at the first minute and second minute and see if they could find any differences. And they found quite a few. In fact, almost exclusively there was differences. And my confidence and excitement started to waver a little bit at this point, because I thought, well, if healthy people are sitting still for 2 minutes, I shouldn't really be seeing any changes. Now, unless something happened in the room, if there was temperature changes or a loud noise or they fell off the chair or something, which there was no evidence to suggest there were. So I asked another student to look into this, and I had another student here, and they thought, well, I would rather look at people who exercise and people who don't exercise. They were working together. And so once again, the filtering I'd applied was the same. So I'd lost the dichrotic knot. So I certainly needed to look at the filtering process in the long term. There were differences again in the area of the actual attractor and in the perimeter. A little bit more pronounced in this time. We can see the medians are more consistently different. But when we looked at the actual differences just from the subjective assessment, again, complete consistent differences, which shouldn't be occurring in healthy people. I mean, even allowing for non-exercising people who may be, not as healthy as we'd want them to be. If they're sat in a room and they're just waiting for their actual, their 2 minutes time, I wouldn't expect changes in heart rate and blood pressure. So my confidence started to wander. I had another student, a final student here, on these type of projects, looking at locations in the body. So I had a PPG sensor on the arm and a PPG sensor on the neck. And you can see that person to person, the quality of the signals in other parts of the body is phenomenal. However, within this particular data set, there were some more marked differences that were actually observed in here, which is making me think that from an analytical point of view, when I'm doing this using equations and algorithms, then there is potentially a use. But this doesn't come back to, is that original table any good? Can I look at a tractor and go, is it rotated? Is it smaller? Is it fat on one side and thin on the other? And interpret some physiological meaning. Now, I got some funding to work with some patients who had lupus. And so I applied this again, and I collected data from healthy students, and I made sure everything was controlled. I got the students to come to a room for 15 minutes to acclimatize, sitting still. Then I got them to lay on a bed for 5 minutes, no movement. And I compared the results. So what we're looking at here is our healthy participants on the left and our patients with lupus on the right. In these controlled conditions, I know there's nothing happening in the room, and I'm still seeing lots of these observations. I did this analysis independently, and I asked a second clinician to look at this independently. I didn't show them my results until after we'd actually collated them all. And we were broadly in agreement. A couple of times we had to go back and compare, but overwhelmingly, there always seems to be some observations, which is really rocking my faith in the concept that this is something you can just use, put a PPG sensor on, and then look at them the same way you would an ECG. So with that in mind, I came to the conclusion, really, the only way to go forward is algorithmically. I've therefore been working on a process, initially with some simulated signals, but I'll be testing this soon with quality collected signals from my own lab, where essentially I've generated 3 different versions of the attractor, thin sides, fat sides, and rotated. I developed an algorithm to follow the trace around and detect changes and mark them. So if there's a change in direction, it goes, it marks each point there's a change in direction. I then used k-means algorithm to identify the clusters and give me a centroid, which I can then use to get variability around the actual vertices. And I can use the location to get angles to indicate measures of change. So, for example, compared to the x-axis. So we're working to progress those. This is absolutely an ongoing process. It's part of my journey. And so to conclude, what I'm left with really at this point is still a series of questions, which hopefully I'll be able to address in the autumn or spring conference next year. But I find myself saying, well, although I was seduced at the start with the beauty, the simplicity, and this table attributing the output to physiological changes, is it really useful? I need to be very careful in the filtering and preparation of signals to make sure I don't take out the actual features such as the dichrotic knots. So I need to work out what kind of filters are actually available. Looking at the authors who generated the algorithm, I've realized they've never used that table they proposed in the original one again, which does make me wonder whether I should have the faith in it, or whether my own observations are that it just isn't as reliable. And then a couple of extra points on here now really are, is it better to keep on assessing this algorithmically, or really should I be looking to move on to more established methods such as the Lyapunov component or recurrent quantification analysis? So I believe I'm probably actually a minute or two over my time there, so I deeply apologize about that. But if anybody has any questions, I'll be happy to answer them.
Dear Dan, can you hear me?
I can hear you, yes.
Okay, your presentation is last of this, yeah? You finish it?
Yes.
All right. Thank you. Thank you for valuable informations about ECG signals. Now I would like to invite Flora or Ludmila. Flora or Ludmila, are you ready? Flora 1. Okay. No. Ludmila, are you ready? Please open your voice.
Yes, just a moment.
I am okay. I am okay.
Okay, Ludmila.
Yes,
you can start.
I'm opening. Yes, I'm opening. Just a moment.
Okay. I'd like to invite the Dr. from Portugal and Ukraine. Okay, Ludmila, you can start. Thank you.
Is visible my presentation? Is okay?
Yes, now it's, yeah.
Yes, it's okay.
Okay, great.
No problem. Okay.
So thank you very much again for the invitation. As always, it's my pleasure to be here with my friends. And it's not first and I hope not last our meeting here. So today I would like to talk about bioremediation of contaminated soils and green technology for sustainability. I'm sorry, is my presentation moving?
Now your presentation's first page is here. Please change your, okay, not problem. Go on, please.
It will be like that. I don't know, some technical problems. The same as yesterday, but okay. So now this environmental contamination by antibiotics and other residues has numerous negative consequences. And one of the most significant is formation of soil resistance and spread of antimicrobial resistance. And of course, nowadays, World Health Organization has classified antimicrobial resistance as a major global health concern. And if you consider that actually soils provide near 89% of world food, soil microbiome plays, of course, critical role in the transmission of antimicrobial resistance to humans. So why this study is needed? Our findings allow us to improve monitoring and management strategies to control antibiotic contamination. It's first to estimate actually a level of contamination by antibiotics and to provide new strategies for bioremediation of soil contaminated by pharmaceuticals, not only antibiotics. Here you can see a diagram, and it's visible that on first place, if you consider pharmaceutical contamination of environment, is anti-inflammatory drug, and on second place, antibiotics, 16%. So if we consider antibiotic pollution, and as I told in beginning that antibiotic pollution affect a lot environmental health, and actually is the reason, one of the main reasons spreading of antibiotic resistance in environment and formation of environmental resistance. In this case, we should consider also One Health approach. So what does it mean? We should consider environmental health in combination of human health, animal health, and as you can see here, that formation of human resistance and animal resistance, environmental resistance, including soil resistance, water resistance, and air resistance, all interconnected. And of course, antibiotic resistance, resistant genes can be transferred through horizontal and vertical, could be transferred horizontally and vertical, and from human to animal, and from animal to human, and of course migrate from environment. The main factors that affect spreading of antimicrobial resistance in agriculture are climate changes. We know perfectly that climate changes affect biodiversity, also ecosystem health, soil microbiome. In our case, for this object, we pay a lot of attention, and of course, stimulate spreading of escape pathogens. I will tell a few words after about escape pathogens. Another important factor is pollution, not only by antibiotics generally, heavy metals, different organic compounds, and so on. And the third factor is overusing of antimicrobials, not only in human health care system, but also in farm. And all those factors, of course, have a huge impact on environmental security, food security, and health security. In our study, we choose several agroecosystems and tried actually to determine how contamination by antibiotics can affect soil microbiome, how can change structure of soil microbiome, and spreading of antibiotic-resistant microorganisms, including escape pathogens. And also, one of the most important tasks is to find bioremediation approach, what will allow to improve generally ecological status of such contaminated soil. And actually, this approach could be implemented, for example, for their agricultural soils contaminated by antibiotics. In our study, we used fluoroquinolone. Fluoroquinolone, a special group of antibiotics. In our case, it was enrofloxacin. And enrofloxacin, why we choose enrofloxacin? Because this antibiotic is quite toxic and has very special way of degradation. So enrofloxacin can undergo degradations by different processes, including photolysis, oxidation, but it's not sensitive to hydrolysis. What does it mean? It means that environmental half-life of enrofloxacin is very long. It could be from 3 till 9 years. Why 3-9 years? Because it will depend from the type of soil, of course, from concentration of antibiotic and the characteristics of environment. And nowadays, enrofloxacin is forbidden for using in hospitals for human treatment, but this antibiotic is quite spreading. I mean, in agriculture is still in agriculture for agricultural purpose for the treatment animals still using. So here you can see a table with functional structure of soil microbiome. As you can see, soil microbiome in different agroecosystems which were contaminated by residues with antibiotic and enrofloxacin, as I told in the beginning, characterized different numbers of main ecological trophic groups. So those agroecosystems characterized as high level of nitrogen-fixing bacteria, and at the same time, decreased number of bacteria using mineral forms of nitrogen, also diversity of micromycetes, ammonifiers, and increased number of oligotrophic and phytotrophic bacteria. So in 5 years, the situation became only worse, unfortunately, and it was expected. So increased number of oligotrophic and phytotrophic bacteria and decreased number of nitrogen-fixing bacteria, more in compare with the beginning of our study. And except that, significantly increased number of escape pathogens. Escape pathogens is abbreviation, first letters of species, which actually include Enterococcus faetum, Staphylococcus aureus, Klebsiella pneumoniae, Acinetobacter baumannii, Pseudomonas aeruginosa, and Enterobacter species, including Enterobacter classe and Escherichia coli. Why those microorganisms is very dangerous? World Health Organization published in 2017 list of microorganisms of priority. What does it mean? That was necessary urgently to find effective antibiotics for treatment people and animals with those bacteria that cause a different kind of disease, because they characterize a very high level of antibiotic resistance. And here you can see that contamination of agricultural land caused spreading and of those bacteria, escape pathogens, and their number increased practically in twice in compare of beginning of our study. So, and here you can see also antibiotic resistance profile. As you can see, those bacteria have enough high level of antibiotic resistance to main groups of antibiotics. So we decided try to find an appropriate strategy how it's possible to reduce persistence of enrofloxacin in the soil. And it was quite a difficult task because, as I told in the beginning, environmental life of this antibiotic is quite high in comparison with our other antibiotics. So it means that deaccumulation this antibiotic in the environment is very high. So we were thinking, what is the main criteria in this case for the method of bioremediation? Of course, it should be safe, cost effective, and sustainable. So we considered different kind of strains of bacteria is the Chromobacter in solitude, Pseudomonas fluorescens, Rhodococcus phenolicis, Bacillus subtilis, Acidobacillus ferrooxidans, and Azotobacter phragcoccum. From this list, we choose for our consortium 3 bacteria: Pseudomonas fluorescens, Rhodococcus phenolicis, and Azotobacter phragcoccum. Why? Because of symbiosis and process of degradation, which actually can support those bacteria. So Pseudomonas fluorescens is highly adaptable gram-negative bacteria and well known for its broad spectrum degradation of xenobiotic compounds, including several classes of antibiotics. So it's like a primary destructor of antibiotic, because Pseudomonas fluorescens can degrade enough complicated biochemical structure antibiotics. So his role in bioremediation acts as the primary degrader of antibiotic residues, and of course can survive and maintain activity in wide range of soil conditions, because these strains characterized enough high level of adaptability. Second was Rhodococcus phenolicis, actually is gram-positive actinonesis, and also well known for degrading aromatic hydrocarbons and phenolic compounds. Except that Rhodococcus phenolicis produce different kind of enzymes that can degrade structurally stable antibiotics. So it's like a second structure degradator of antibiotics in our case. And third one is Azotobacter phragcoccum, and key properties is free-living nitrogen-fixing bacterium that actually enhances soil fertility and can produce also growth-promoting substances. Except that also can produce antioxidant enzymes. So actually, role of Azotobacter phragcoccum in this consortium was like to improve, allow to improve soil health, microbial balance after detoxification. We provided laboratory studies. So we created this consortium, PARC. So Pseudomonas fluorescens, as I told, Azotobacter phragcoccum, Rhodococcus phenolicus, and in such quantity. So 6 million chloroform units per 1 milliliter of water, 3 million, and 3 million of Rhodococcus phenolicus. And the duration of our experiment was 180 days. So in beginning, concentration of antibiotic in the soil was 23,800 microgram per kilogram of soil. On control, it was 21,600 microgram per kilogram of soil. I mean, after 180 days, yes. So from 23,800, let's change it to 20,600, of course, because we have some microorganisms in soil which actually can support this process. But in soil samples where we added our consortium, as you can see, concentration of antibiotic decreases practically in twice. So, and it was 12,300 microgram per kilogram of soil. So it means that this consortium quite effective and could be implemented on practice. So why this consortium is effective? Because of synergistic degradation, resilience and adaptability, and of course, it will be useful for soil restoration because we use it as a bacter from cocoon, which actually can support soil health. And because of more quick degradation of antibiotics, it can implementation of such kind of bioremediation can reduce resistance risk. What does it mean? That effect of impact of antibiotic contamination will be lower because of the time. So as we can see, contamination by antibiotics in environment can cause a lot of negative consequences. And the results of our studies show it that actually antibiotic contamination can affect functional structure, taxonomic structure of soil microbiome, and except that has a negative effect for spreading antibiotic resistant bacteria, including escape pathogens. Results of our study showed us that number of escape pathogens increases during 5 years more than in 2 times. And result of our search for bioremediation strategy show that this consortium that we created and proposed for implementation actually gave positive results. And of course, we need additionally to provide some experimental data, but results were positive, and of course, with such approach of bioremediation, we can reduce negative effect of antibiotic contamination. In our case, we talk about soil. So thank you very much for your attention, and if you have some questions, I will answer with pleasure.
Okay, thank you, dear Ludmila, for valuable and good informations. Okay, dear Flora, you have a present or?
Yes, yes, I have one.
Okay, Rudy, you can start.
Yes, just a moment.
You can use bottom of the screen and share.
Yes, yes, but
Maybe you are professional presenter, you know.
yes. Okay.
Yes.
Can you see?
Yes, now presentation here. Please.
Yes, okay. I have to present the recent study of me and some colleagues of my department related to the impact of GDP on tourism, a study of European countries. And the outbreak of the COVID-19 pandemic seems to brought global tourism to a standstill in the years following the pandemic. Around 1.1 billion tourists traveled internationally in 2024. According to the latest World Tourism Barometer by United Nations Tourism, the tourism sector has fully recovered. The year 2024 brought good news for global tourism, according to the United Nations World Tourism Organization. So we see also in the figure 1, the COVID-19 pandemic also affected the global GDP. World economy was contraction in 2020, with GDP falling to 82.68 trillion US dollar from 85.13 trillion in 2019. However, global GDP recovered in 2021 to $87.93 trillion, And after in 2023, 1977 at 2022, and 93.35 in 2023 respectively. As introduction, we have to say that is a bidirectional causality relationship between tourism and GDP. In 2015, a bidirectional causality relationship between tourism and economic growth was the main finding in a study of 12 Mediterranean nations. In order to achieve high economic growth, policymakers should focus on developing the tourism sector. On the other side, tourism affects economic growth. Many other studies have analyzed the impact that tourism has on economic growth and vice versa. In a paper that includes long-term data of the Spain economy, the results indicate that during the last 3 decades, economic growth in Spain has been sensible to persistent expansion of international tourism, according to Balaguer and Cantavella 2022. Economic growth affects tourism. Khan and Munir 2019 provides an overview of how GDP influences tourism development. It suggests that higher GDP can lead to increased tourism activities due to greater disposable income and improvement in infrastructure. Methodology, we have the objective of the study is the main objective is to assess the impact of GDP on tourism. Also, the study aims to assess the impact of factors affecting the country's economic activity, GDP, such as trade and gross capital formation. Another important goal of this paper is to assess the impact of logistic performance of a country on the country's trades. And the last one, the impact of innovation of a country on the country's gross capital formation. The methodology used the data sources and definition of variables. The variables are tourism, total tourism expenditure, GDP, economic activity, trade, the sum of export and imports, GCF, gross capital formation, logistic performance index, innovation, global innovation index, and in the other column are the measures in US dollar, etc., or the two last one are index, and the source where the data are taken. The data of 46 European countries of 2023 for each of 6 variables are used, organized in a cross section. Also, to compare the data of the 2023 with the years before, we have made the same calculation for the 2012 and 2018, and as we see later, the results are the same for the relationship between these variables as in 2020, 2012, 2018, and 2023. Model construction, we see the model here in a diagram of structural equation model. And we have used AMOS software, and we see tourism as a function of GDP, GCF, trade, and logistics. The variables are presented within the boxes that are 6. Single-handed rows like these indicate causal relationship, and the double-headed rows indicate covariance between variables. Evaluation methods. Structural equation modeling requires data normalization. Once the model structure is built, the model fit must be checked. 8 tests indicate whether there is a significant difference between the observation and the expectation, regression weight, and the last one, squared multiple correlation. The analysis of results, the first one, squared multiple correlation, we have detected that dependent variable tourism is well predicted by the independent variable GDP. The dependent variable GDP is well predicted by the independent variables trade and GCF. The dependent variable GCF is well predicted by the independent variables innovation. The dependent variables trade is well predicted by the independent variables logistics. As we see by the table, 67.1% of the variance of the tourism variable is explained by GDP. 98.7% of the variable of the GDP is explained by the set of variables GCF and trade. 47.8% of the variance of trade in this model is explained by the logistics. 27.7% of the variance of the GCF variable is in this model is explained by the innovation, as we see in the table. Analysis of the results is we see the results for the years 2012 and 2018. We see the same diagrams as we saw in the 2023. That means that the situation or the relationship between these variables is the same and is not dependent from the different years. As a conclusion, we say that the study conducted using structural equation models highlights the interconnection between GDP, its contribution factors, and the tourism sector across European countries. The findings indicate that first, logistic improvement and innovation significantly influence trade and gross capital formation, both of which are critical components of economic growth, GDP. This highlights the importance of interesting logistic performance and fostering innovation to stimulate economic activity. Secondly, the analysis reveals that trade and GCF together account for 98.7% of the variance in GDP. This suggests that policies aimed at improving trade and capital investment can significantly improve GDP, which in turn boosts the tourism sector. Economic growth, GDP has a positive effect on tourism development. The model estimates that GDP explains approximately 67.1% of the variance in tourism expenditure, indicating that as economic activity increases, tourism is likely to expand as well. The comparative analysis using data from 2012 and 2018 demonstrates the model stability over time, suggesting that the relationship among the variables remains stable for these different years of the period. The results suggest policymakers to prioritize initiatives focused on improving logistics, encouraging innovation, and enhancing trade as a means to stimulate economic growth, which boosts the tourism industry. So we can finally say that economic growth and tourism are both related with each other because it's a bilateral connection between them. Economic growth affects tourism, and tourism affects the economic growth. Thank you. Brother, you are on the Amy.
Thank you, dear Flora. Thank you for valuable and good information about Albania tourism effect of GDP. Okay, all presents are ended and finished. Now I have one question about your present. Dear Flora, how do you think about artificial intelligence of using in economic studies? You can say any example or other Understand me?
Yes, 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 I understood. I think that in every field, the artificial intelligence is giving impact. Also in economy, of course, but if in our studies we control too much, we have to take care for the data taken from artificial intelligence, because of course we use for some data or for some conclusions, but not to use directly from them, because it's difficult in economy to give a result that is not proved by the data. So as you see in the paper, we had a lot of sources for our data to be true, to be real data for the study. But of course that now is everywhere is speaking for the artificial intelligence. So of course we will use the data from them. Maybe in the moment I can't say a real example where, but everything now is related with artificial intelligence. As the China has built the first hospital only with robots that work there, what not to speak for the artificial intelligence is the main.
Thank you very much. Thank you. Now this time is session, the finish of this session. Thank you for support. Thank you for previous Congress support. Maybe
it was my pleasure, and it will be always my pleasure to be part of Imascon. You know, I have been there from the first one. So as I said before, I wonder to it that when I see the 14th one, oh my God, that means that are 7 years. That
Yes.
and this conference, I am sure that will have a long time existence, because
Yes.
it's very nice, and we are always honored to be part of this conference.
Thank you. Thank you again. Next will be offline, inshallah.
Inshallah,
or
it will be our pleasure.
Milan or Albania, yeah, maybe in Tiran or Dures. Flora, yeah. Flora, are you there?
Yes, of course, you are welcome to.
Okay, thank you again. Bye, Flora.